install sheet cam, then it will open. First thing I have to do is fix the post processor. Machine, post processor, import post.
Just in time.
It is in here.
We will help.
Open.
He's just doing the install
Layout.
of this again. So, yes, good time.
Then I have to go to the working envelope, which I have to put the dimensions there. Cable display should be the same. Okay.
Well, that's sorry.
Now we go to the machine.
Yeah. It's just
Options. Draw. This will be as a default. I would like to prefer to make it 0, 0 from here. And this is the material size.
Well, it works.
In our case, it is 500 by 500
Okay.
in our case. Then I have to load the tools. So open tool set.
Yes.
These are the tools.
Yes.
Open.
Yeah, I think so.
And we have all the tools here now. And we can start
Which one we gonna select to do this job now?
now.
The tool here.
Let's start with
He said.
the Excel file first. So I have to go File, Import Drawing, which is in here. Then we have this one, Test. So metric, I want this coordinate here, 0, 0. And then we have other options here. We can either say I want it to the drawing origin, center on 0, 0,
Yes.
current position, and specify a position. We can do that as well. Okay? Now, as you can see, we have two colors there. We have the red on the outside and the yellow in the inside, which means that this particular file is one layer. And since this is closed, and the holes are in a closed loop, it will automatically know that this is inside and the other, this is inside and the other is outside.
Okay.
So now we have to generate the toolpath. So I go Operations. In this case, I have to choose outside. The layer is default. I have to choose the layer. Now I will choose 2mm mild steel 45 amp.
Okay.
It depends what kind of consumables that you have.
Yeah, of course.
I set up a lead in of 5mm, and the lead out, I don't need it in a plasma. I don't really need it.
Okay.
So I just press OK, and it will generate the file. If I need, for example, as you can see now, yes, where is the yes? This is S1, this is S2, it means start 2, start 3, and start 4, okay?
Yeah.
Let's say, for example, I want to change. I can go quick cut sequence. Number 1, I want it here this time. 2, I want it here. Normally it will generate by itself, okay? 3. 4. Always the outside profile should be the last cut. Again, if you want to change the direction of the lead-in, you can, whatever you want. So I will make end sequence. Can I take this and put it here? Okay. So file, post processor, and it will generate the file. I will go. Let us do. Folder. Plasma. And save. So at the moment, I already know that there is a fault. When we run the post processor, it's generating a .tap. I'm not sure if this one can open it .tap, but I'm sure it should be .txt.
TXT.
Yeah.
Okay.
So I'm going to fix that. So I go machine, post processor. Here is the output file extension, txt.
You are basically converting.
So the machine will read it correctly. Post. As you can see, we already posted here in my .tap. Now I'm going to put .txt. So let us now do another kind. Save changes, no. Yes. Save. Now I'm going to make another one, another file, which is different layers now. I want this point. Okay. As you can see now, they are all red. So the machine, the CAN does not know which is inside, outside. So what I have to do is now, I will go inside offset, in this case. Layer, I don't know which one we choose. Yeah, this is the, you see they come white now. So I'm going to cut that one. And we make these 3 holes. Now I want to make the outer contour, outside this time. Layer default. Okay, and we have generated the same program, the same part with different layers now. So I'm going to save it as well. Okay. Any questions about this?
No, really.
What about if you try to make a file, and you try to generate, at least one of you. So if there is any mistakes, I can
Okay.
I can see.
So what I'm
Oh,
going to do
sorry.
here. So what I'm going to do here.
So let's start from the beginning. Close it.
Close all.
Close.
Okay.
Jeffrey,
Yeah.
Lena has a question.
Yeah.
Is it necessary to create the material in the drawing?
No, it's not necessary. No. It's like 200 inch, which comes, So you will know right away that you have the wrong setup. So let's change it again now. This is the machine, okay? And this is the part, the sheet that we're going to cut.
Can you
So make it close. No save.
Same job.
No, no.
Okay.
No.
Yeah.
Open it again. Now choose the file. Import drawing. File. Import drawing. Come down. Now choose the file. Okay. Now choose metal. Now you can generate. Now this is one layer, okay? Because it already knows.
Yes.
So you can just make one operation. Okay? Now outside, make it inside offset. So you will know the difference. It will change everything then.
Yeah.
Okay, press OK. Now, as you can see, the lead-in is from the outside, not from the inside. So that's why we have to change the operation. If you go in here and edit,
Double
double
click.
click, I think it works. Yeah. Now, instead inside, make outside. And it will change. And that's it.
Yep.
Any questions about this?
No.
Can you like put a vector to not be cut?
Yeah, can you hide the layers?
Or like yeah, if you
Yeah,
didn't-
yeah, yeah, yeah.
If you didn't want to cut the outside.
Yeah,
parts,
but you have to make different layers then.
Okay.
and that would be on the file before you bring it in. You can't do it on this program.
Yeah. And let's say you have a line that you want to cut with 0 offset, which means the care fit will be on the line.
Yeah.
So if the care fit is 2 mil, for example, you have 1 mil on this side and 1 mil on that side. You can do that as
Yeah.
well.
But like you couldn't say not to cut the square now. You would need to go back to your file.
Yes,
Okay.
yes.
You're talking about the margin cut.
No, just like if you didn't want to cut the outside border.
If you have
or
the
anything.
if you have the file
Yeah.
generated in one layer,
Yeah.
you cannot say I don't want to cut the outer layer. You have to make a file with 2 or as much you need layers. For example, it will work mostly in the house like that.
Yeah.
For example, you have drills 2 millimeter, you want it with tool 1.
Yeah, yeah, yeah.
Drills 6, you want it.
Yeah. That's part of toolpaths for that. Yes or no? Okay.
Okay,
Next stage.
this is done now. If you want to ask any question, let me know.
No, that's clear. I mean, when we've done finished, we save it on the memory disk.
Yeah.
Here.
Yeah.
Okay.
So we check.
Okay, we can just cut new ones, right? On here.
New.
New bellet, we can put it on here.
What? Depends on screw.
We can make whole machine.
Yeah.
Now let us
Need to get your CNC machine.
switch off the machine, okay? And we start from the beginning.
Yeah.
You will never switch on and off right away, okay? You just give some time.
Okay. Wake him up.
No, because there will be capacitors.
Yeah.
They need to drain.
So one question here, because we have another equipment in here, sometimes that fuse just pop up. Is there any problem with fuses? We have to have spare fuses to
Maybe
replace?
there are 2 circuit breakers that
We're not touching it.
if they go off, they will, you will see them like So we leave it to start.
Yeah.
So now, since we switched off, the machine does not know where the head is. I moved it, it doesn't know.
Because it will be going to 0 point values.
Now we have to make a reference or a homing in that
Yeah,
machine.
yeah.
It's the same.
Yes. I understand.
The newer machines are not like that. You just switch on and it's absolute and they know where they are. So now the machine is going to check all the outputs and inputs, and then it will start the PLC. If it is safe, it will start. If it's not, it would not start. It keeps checking everything first and then it will start. Then you have to reset the emergency, but I will show you. It will take some time to start.
What's the thinnest metal you can cut on here?
The thinnest,
Yeah.
if you go fine cut, I think 1 mil is okay. The problem is mainly because you have space here, or you can add more here.
Okay.
When it goes and finds the top of the material, this will bend because the shape will be thin and it doesn't find the correct height.
How is it finding that? Is it like
So we will do
conductance or okay?
Now there is a floating torch. The torch is floating, so when it goes and touch the material, it will find the switch and it will find the height.
Is it adjusting to the?
You don't need to give it any.
I mean-
Z is independent axis. Yeah, if it goes like that, then there is another operation. It is with the voltage control. So it will read the voltage from there, and it will try to correct the gap. So eventually, the machine will start like that always. Okay? So let's go briefly on all the options that we have. So this is the run page. This is where normally you have to cut. And as you can see, the axes are blinking now, which means that the machine does not have reference. Then we have the shape. You can generate a shape from here. These are parametric shapes. Did I check it? Ah. So you have this. These are all parametric shapes. Like edit. When you go in these, it will show you, for example, I choose this. This is the PCD of the 4 holes. Number of holes.
6.
I can make like 6, and then it will generate 6 holes. Blah blah blah. But this is something that you can play with, and you will understand right away. Now, if I choose this, and I choose another. Check. No, it generate the other one. I think we have to make reference first. So this is shape, this is remote assistance. If you need help from me to check the machine, it will go and find the team viewer. Obviously it's not connected to the internet, there's no numbers. Editor. I don't think really you need to adjust this if you need to edit a particular line in the code. But eventually you will never use that. You will generate the file again.
Just goes to G code.
This is the reference. So now I can choose either 1 by 1 or I can choose all the axes. So if I choose this one, make cycle start. And then it will find the position. And then deploy.
Can you put in like like tabs in the drawing, like micro tabs?
Yes, okay.
Yeah.
In sheet cam, yes.
Okay, so that's a.
So the part does not fall down, you mean,
Yeah.
if you have tiny parts. Yeah, you can.
So it's homing now.
Hmm?
Is it homing?
Yeah. Now it's making the hole. So first it will make Y1, then it will correct the squareness of the bridge, Y2, and it will make the Z. Obviously these has to be green to start working with the machine. So now it's done. Now we need a work file. So when I put this one, I will go here, D, E, sorry, and I do the file plasma cuttings. This what files that we generate. I'm going to try this tap file, just in case. I will move it here. I want to check if it works. I think it still works. Yeah, it works. So,
You don't
but
have
to be honest, it should be TXT.
Okay.
Now, we can move the machine. Can we have a plate? No?
They look good.
I don't know if it fits here, to be honest, but we can check. So what I'm going to do is, first, a good idea will be, if this one will be square with the machine, then you have like a piece of flat bar here, you just hit it there and start. But let's do it the hard way, this way. So I'm going to align the machine in the place. It's not necessary because the machine can also rotate the part. More or less we are there now. So let's say I want to cut this one, zero the part. Always cycle start, because in the 2016 onwards was not allowed to make a soft key. You have to make a hard key to make the zero. Even the start, it's not allowed anymore. From 2015, I believe, onwards, you can't make a start button from the soft. It has to be a hard key always. So, I'm going to make trial now, and I'm going to check with the plasma torch now, if it fits there. So I'm going to choose trial. This is the feed rate that I have. If I want as well, I don't need to cut these now. So I can go option. I will go next cut, next cut.
So instead of creating a layer, you can actually skip them here?
Yeah, you can. So I'm going to start like that. As you know, it doesn't fit. So now we are center on the torch. Okay. Now I'm going to do another thing. Trial, but with laser. I will check here.
This is going to be one of my questions. How do you? How do
I
you
believe
align
this,
that laser?
this
That
is
looks like-
very practical for the students to understand what is happening. So I will start. And now instead of the torch, it will go on the laser. So where is the laser now? It will show where the machine is going to cut.
Can you scale down?
Yes, you can scale. You can, if you want. Now let's say I want to cut 2 of these and 2 of these, so it comes 4. Okay. Keep the screen. All right. 2. As you can see now, the parts are apart. If I press auto, they will grab them together. Okay. This
It's
will-
like array.
Yes, it is an array. Columns and yes, you can scale if you want. For example,
Let's do 90% so it fits inside there.
yeah. So 90% it will come 0.9. Again, auto. And it will fix it. Again, you can rotate the piece. Let's say I want to rotate 10 degrees. A bit like this. You can make mirror on X, mirror on Y. These are all things
Can you
that
do mirror one of them?
Yes. Yeah, one part? No. And the array? No. Because you already generate an array. You can't make one of them only. Reset values. Okay. There is another option. I have to find where. Let me check. Yeah. Align plate. Not in your case again, but let's say you have a 50mm plate on this machine. How can you rotate it precisely and you want to cut the border? So you go with the laser, for example. I think we need to adjust the laser, okay? And then it will tell you move to bottom right and then press P1. So we are on the bottom right. That one. Okay, P1. Now it will tell you move to P2. So now I'm going to do it on purpose, okay? I'm going to rotate. Let's say the sheet is rotated that way, okay? I will do this one. And it will fit the part on that.
When would you need P3? Or is that
It depends. If you are in this one and you want to go this way, it will take P2. If you are in here and you want to go vertically, then you have to press P3.
Okay. And can it do that with the conductance at all? You know, you said about it finding the height with the sensors in here. Can it find the angle?
No, that you need a probe
Okay.
to do that.
No, I'm just trying to understand.
Trying to be lazy.
Yeah. basically.
Sorry, I'll go.
Okay, gotta go.
Thank you. Nice to
Okay.
meet you. Nice.
Thank you. I'll see you soon.
So, let us check now. Yeah, I need to tell you something else. Let's for example, we are here. And we need to know where it was our origin, the 0, 0. I can go displacement. If I stay absolute, I will go in this position, 0, 0. There is some, I need to check about this, because it should be Y here, not Z. There is I will check about that. I think it will go in this position only. It's good that I am showing this to you. Now it's going to make X and Y. This was our origin. But I will change this and I will fix it. Now, if we go to relative, okay? Relative now from this point, if I want to go, for example, on the x, I don't know, maybe 50. I just press 50. I will press this and always cycle start, okay? So it will go 50. Now, I will tell you the difference, okay? If I go 0, or sorry, 10, okay? Now what is going to do? The machine is going to move 10 millimeter in that direction because it's relative, okay? It will go like that. Now, if I go in absolute, the 10 now is not going to move this way, it's going to be here because it is in the absolute.
From where?
From the origin. I will fix that later, okay? Any questions about this?
Can you record it? I want to go and see Dean.
No, it's good so far.
It's very easy.
Just finding your way around.
You need to play with it. a bit.
Yeah.
We went all this one we went, yeah. Cutting manual. This is nice too, as well. When everything is on, okay, and you want to cut, for example, a line manually, or this way, or that way, whatever, you just press and hold, it will find the height, everything, and it will go that way. If you want to go that way, it will go that way. When you stop the button, it will stop the machine. Work mode. Yeah, I'm going to have one to be there. Info search. No, you need plasma. I think I should disable the oxy-fuel here. Because the machine is torch active now. It's plasma. If I choose this, it's oxy. So we can have, well, I should disable this because it doesn't work then. It should be like that all the time because you don't have the oxy-fuel.
Is it just running off compressor?
Yeah, this one, yes,
Yeah.
the plasma, yeah. Now, we need as well to make some calibration, but let's say I want to cut this joint now, okay? So I have to go more, this is important, this is the main thing that you have to learn. I go database, I choose the material, which is steel, I choose the thickness, which is 2 mil, I choose the process current, because you have different consumables, okay? And I think we should download the manual of this. Or it's in here, maybe, I don't know, because I did not supply this machine. No. But I can send the manual of this. There is all the cutting process. So in my experience, okay, I would not cut 65 amp in a 2 mil. I would go 45 mil, 45 amp, sorry. So these are the cutting parameters that the machine needs. So the arc voltages should be 130, piercing height 150%, blah blah blah. These are all automatically set.
Okay.
You just press apply. Eventually there is other cams that from the cam they send this ID and it will automatically will call that database.
So, but those settings
In
or
this
those
one, no.
kind of manual,
Yeah, of course.
like if we, but yeah, it's sort of,
You can verify
yes.
these
But
parameters
but
on the manual.
You've already done it. It's,
Yeah, yeah,
okay,
yeah.
okay.
Apply. So now I know that the feed rate is 5280. I'm going to check. Feed rate is 5280. Any questions? No? It's quite easy, I don't think.
Yeah.
But you should
per minute.
practice it.
Okay, cool. Okay, sorry. I thought we were working in millimeters per second, and I was like, that's fast. No,
No,
but per
no.
minute. Good. Yeah. No, that's fast.
It's
Like,
very
uh,
Well, that will be, I think, Mach 3 or sound of speed that will be if it is. No. Ah,
So is it ready for cut then?
what? What do you want to do?
Cutting to see.
Yeah. Now we need to calibrate
mm.
the plasma and the voltage. So let me check something. So we're going to do this one. The plasma should be off all the time when you remove the consumables from there. You have to remove this. In the manual, there is all these explained. So then you have to order these part numbers. This always remains the same. This one. This is the electrode. This is the nozzle. This is the shield. And this is the torch body. So now, this is 65. This is 45. Mainly what I need to change is,
Cool. It says.
yeah, this is 45. So I will put it like this. This one. And to be honest, you should change this because this is a 105. I don't know, but I know with the hole because the hole is big. And the guy did not have this, so I am going to work. We will not have the best cut, obviously, because the setup is not 100% correct. Yeah, this is 105. But at least we can test. Something else, if this will hit, it can break. So I'm going to do it to show you. It will come in emergency and this will go off. Then, when emergency is placed, you have to do the reference axis again. You see them? No? Oh, they are. So we have to go back here. Reference all and start.
Okay. You can kind of copy those numbers down, and it should find the same
Yeah.
position again. Well, if it was on 0. Yeah, I guess could you find the same 0 after this? That-
Yes?
Yeah. Okay.
We can test it now. So you told me about this. If I go displacement, I will go absolute 0, okay? 0, 0. Press start. It should find that part.
Nice.
So now, I want to start this. And I'm going to do the calibration. The calibration, I have to go here. So let's go on this first. No, that's not 2.
6.
No, it's not 6. That should be 4 or 5. I believe 4. Can I use this?
And I think it probably is
4? Yeah, 4. So to calibrate, I need this one to be 16. Now let's say I will make a mistake here. And instead, I want to go 16. The machine, it will tell me you can cut it with 65, you can't cut it more. Okay? I'm going to change it for. Now we have different parameters because the material is thicker and the tool many. So the set arc voltage is 130. This I really need to check, it's 1.5 and the field rate is 1800. I'm going to make a play.
Maybe ask you to go here to the container.
Let me check.
No, that's not. Look this
No,
container.
it did not pass.
I don't know somewhere.
You have to make sure that that will pass.
Ask him.
I'm going to do it again.
Where
Okay?
is the container?
Steel.
Is one of those here.
Where?
This between parking.
Where?
This between parking.
Now it's okay. Now, I need to check. I have to go there. Now I'm going to check the process. That it should be 1.5. Maybe we need to adjust. I don't know actually. So I'm going to take a touch of the material, which will find the material, go up, and I should have there 1.5 millimeter clearance, which I don't. I'm almost zero there. So I'm going to adjust it. Yes. That should be. Because it's zero. Make it 2. Back. Yeah. More or less we are there. It doesn't very accurate. Now the feed rate was 1800. So I have to change this one. 18. And the voltage was 130. I bring that from the database, okay? Database. So the R voltage is 130, the feed rate is 1800. That's where I bring these numbers. Now, we should switch on this one. Yes, again. I have to attach the positive lead with the sheet. Normally this is clamped with the tank. So, but for now I'm going to do it here. Yes. Put this one on? No. Okay, works. Now let me show you a bit of this. This one, and you have like an expanded metal, so the machine can keep continuously cutting. This one is the normal way how to work. This one, in this case, you don't use it because this is gouging. For example, you need to weld and you need to make a bevel cut or clean a weld or something. So normal, you should be there. Now, we install the consumable, so it's 45 amp. So this has to be 45. Okay? Now we should test. And it should go that way, okay? 1 meter. We don't have 1 meter cut there. It's not more than 400. I should put this one. This you should not do it. But it can happen, you know. This, what I'm going to do is to calibrate the voltage of this with the height of this. So I already set up the number. I'm going to cut, and then while it's cutting, and I will find the correct height, I will tell update. So now we're going to start, okay? Be careful with your eyes. I just press
Moment of truth.
cycle start. So now I want to check the laser. You have to be careful about the laser. You see the cut that I did? This should be center in the cut. If you move this, it can lose the coordinates. And from here to here, I need to measure that thing, and I will put it there.
Yeah, yeah. Yeah.
Let me go from 10.
Yeah.
85. Now we'll go offset. You see, now it is 100. I should change that. That should be 85 or 86. Small 86. Okay, and this one should be 0. And the y came to 0. So on the y-axis, since the laser, the crosshair is in the center of the cut, that should be 0. And the offset from here to here is 85 because I measured it.
You are measuring from the very tip of the cut. Yeah.
Now there is another parameter should match. Yeah. Now it's the other way, okay? It's minus 86, not plus, because we are switching the torches. And the Y is always there. Okay, this is the override feed rate. This should be more or less always 100. Okay, but if you see like the machine is not cutting well, you can go a bit slow or a bit faster. This one here.
So it's like a percentage or
Yeah.
yeah.
Now let me cut this part. So now I want to make sure that the part will fit there. So I'm going to make 0. Start. Trial and laser. So I'm going to check with the laser if it fits. So now start. No, I have to move it a bit more. I see what, yeah, we have over there. So what I need now is reset, okay? I will reset everything. Now I'm going to move, I don't know how much, maybe this way. 0. Okay, I will do it again, just to be sure. Okay, it fits. I hope from the up, yeah, it should fit as well. Okay. Now we can cut. Now we can press start. We'll find the height. But as you can see with the water, there's no thing. If you put it down, it will be this way. And again, we are in a bit low speed because we have a lit. You see this dross here? That means that the machine is moving slow. You have to go a bit higher. So now, I would like to measure it to see if the machine is working perfectly. This was 200. Yeah, we are there. 200 by 200. Yeah. It's done.
Good, okay.
Now, honestly, okay, that is working really nicely as a plasma. Plasma is not so accurate, okay? But for a plasma, it's very good.
No, so yeah, you're saying you would go a bit
This is
faster.
what we have.
If you go a bit faster, you won't have this.
It's a clean cut then.
For me, it's good.
Okay.
For a plasma, this is what you expect from a plasma.
Okay.
From a water jet, it will be
Yeah, of course. Okay.
perfectly.
So that
The nice thing
I've
on
never
a
seen a plasma work,
it's
so
cheap,
yeah.
according to laser. Or
That cable is just attached to water and everything. It's not danger to life or anything like a shock.
No, absolutely no. So what do you think? We should cut?
That's what my concern.
yeah.
No.
It's useful. Cool.
What about if you, by yourself, generate a small part from A to Z, you post it and you cut it?
Yeah.
Why not?
Yeah. Why?
Huh?
Really?
But you have to generate the DXF file, okay?
Well,
From